All right. So good day, everyone. Today we are going to um, learn about how to use GeoGebra for you to go through your review of functions topic in your learning guides. I will break this session into three different videos so that they will be easier for you to access at your convenient time. Okay, we will begin with the first topic in your learning guides, which is evaluating functions. So how can we evaluate functions using GeoGebra? We will use the practice exercises from your learning guides for this class. Right. So let's see. Um, may I share my screen now? Uh, as usual, I will share a composite screen with your GeoGebra on one portion and then your examples at the right part. So, how do we use GeoGebra to evaluate functions? So, firstly, you have to input a function in your GeoGebra. So how do we do that? So let me just move our graphics window. Sorry, there. Okay, I think that's much better. Okay, so for example, we have in number one, you have f of s. So you just type f of s is equal to 2s squared minus 1. So, sorry for that. There. So you will see, of course, there a trace of a parabola because 2s squared minus 1 will show you a quadratic function. Um, and you are asked to evaluate this quadratic function on three different points, -2, square root of 3, and an expression square root of 1 minus s. So firstly, how do we evaluate f of -2? Very simple. You just type in f rather of -2, and you will see there 7. So it will show you that f of -2 is 7, which is true enough. When you substitute -2 into the expression, you will have 2 times the square of -2, which is 4. So 2 times 4, that's 8 minus 1. Indeed, it is 7. Okay. Now, supposing we are asked what is f of square root of 3? So again, you just type f of square root of 3 and you will get 5. How is it 5? We test again. So square root of 3 squared, that's 3. So 2 times 3, 6 minus 1. And indeed, it is 5. Sir, would GeoGebra be able to evaluate a function with an expression? Let's try. I'm not quite sure. So let's have f square root of 1 minus s. And okay, so GeoGebra will be able to give you another function g of s, which is f of square root of 1 minus s, which is as given there in your screen. However, GeoGebra is still limited in its function. It cannot simplify for you. Okay. So I guess this is where you still have to use your paper and pencil because you have to do simplification of this expression. But can GeoGebra give you the graph of this expression f of square root 1 minus s? It is able to. Okay, you can still at least be able to find the domain the range, etc. for this new function f of square root 1 minus s. All right. I will leave that to you as an exercise, how you will be able to simplify this expression. Okay, right. So let's move on to the second item. You have a trigonometric function this time. Okay. You have a g of t rather. G of t is equal to sine. Okay, be careful with this one. This expression says the sine of 2 times t. Okay. This is not the sine of 2 quantity times t. So in GeoGebra, you really have to write that as within the quantities 2t. Right. So you will be able to see that from the graph, it is a sinusoidal function because it is the sine function, right? And how do you evaluate these functions in these different uh, given x values? Very simple. So you just write them down. For example, g of 0, you wish to know what is g of 0, and there you go. It is 0. Okay. You will see in the input bar that g of 0 is 0. If you want to see this as a point on the graph, then you might occasionally want to indicate this as a point really 0, g of 0. And you will see that your GeoGebra, okay, so let me just highlight that. Okay. You will see now that your GeoGebra is able to point to you in the graph that at 0, okay, g of 0 is indeed 0. We will see more of that uh, in the following exercise. So what is g of pi over 4? You can write pi conveniently in GeoGebra by just typing pi, okay, and then divided by 4. So g of pi over 4, it says here is 1. Supposing you want to know the point, the exact point, pi over 4, g pi over 4. So let's see. Let that be point B. Point B is pi over 4, okay, and g of pi over 4. And you will see there. Oh, I'm sorry. Let's g of pi over 4. There. All right. So you will see in your graph that indeed pi over 4, g of pi over 4 is 1. Okay, so if we are going to be trite about it, oh, by the way, you can change the scaling of the x-axis if you want to see your x-axis in terms of pi. Okay, so let's see that. First, we highlight that point, that be point red, okay, with para mas claro. And then you can, like I said, you can change the x-axis by clicking on, okay, the let's see, yes, okay. So clicking on the x-axis, and then you go to this bar, okay, and you go to this units, and you use pi. Okay, that will show you, I think, yes, we can. That's all right. So if you notice now, our x-axis has changed in scale. It's no longer in 1, 2, 3, 4. Even if your y-axis is still in 1, 2, 3, 4, 5. It is now in terms of pi. It is now in terms of pi. And you will be able to see that pi over 4 is somewhere here, or a quarter of a pi. Okay, finally we find what is g of negative pi over 6. So just write again, g of negative pi over 6. You get there. If you want again to see the point, okay, where this is exactly in the graph of g of t, then you can always write, let that be point C now, negative pi over 6 g of negative pi over 6. And there you go. And you will see that it is at negative 0.87. I would venture that that is a square root of 3 over 2. Okay, so let's just, for contrast, okay, there. All right, so you are able to see now in the on the graph of g of t the 3 points we are talking about. Okay, the 3 points we are talking about. By the way, all right, so there you have it. How about the last function? So how about the last function? Can we use GeoGebra to evaluate this last function? Let's see. Okay, right. You will see, let's write h of z, h of z is 3 divided by square root of 2z minus 1. Okay, there. So 3 over the square root of 2z minus 1. So just like before, if you want to figure out what is h of 5, then just write h of 5. And if you want to see the point on the graph, then you write 5 h of 5. Uh, Very easy. Okay, so let's just right. How about h of 2? Yes, we can do that. H of 2 is at 1.73, and we can point on the graph what is 2h of 2 using GeoGebra. And there you go. Okay, so you will see that we are able to find as well the point on the graph. Now, how about evaluating this function at an expression t plus 2? Okay, is that possible, sir? Let's try. Can we evaluate h as t plus 2? Yes. Okay. You are able to. You're able to evaluate this now. You have a new function, in fact, f of t, which is h of t plus 2. But like I said earlier, we are not yet at the point. GeoGebra is constantly being developed. So we are not yet at the point of development in GeoGebra that it is able to simplify for us expressions. Okay, so this I will leave this to you now as an exercise on your own, how to simplify this expression for h of t plus 2. But to answer our question, is GeoGebra able to help us to evaluate function? Yes, it is able to. And we have shown in this exercise, this set of exercises, that we are able to. In fact, we are even able to make use of it to point to us the points being evaluated on the graph of the function. Okay? So there you go.